Hello everyone, so it's Cole here and we are going to talk about vectors, and this time you are going to look at how to make an equation of plane that connects 3 points. So let's start. So let's say we have 3 points P, Q and R, and each of them they have their own coordinates. So we want to find a plane that connects these 3 points. So there are a few steps that we have to follow. And the first thing is that we need to find the vectors that connect the point P, for example, with R, which is what we write as PR with the arrow at the top here. And we need to find the vector P to Q. So in order to find PR, this vector, basically you take the coordinate for R minus the coordinate for P, and this will give you PR. You do the same thing with the PQ, and then you will end up with two vectors. So the second step that you need to do is to find the vector n, which is perpendicular to these two vectors. So I'm sure you know what to do, right? So you will use the cross product between these two vectors, and then you will find this vector n. Now the third step. Now this third step is a little bit arbitrary. If we look at this, basically you need to kind of imagine you have one point somewhere in this plane that you're going to create, and this point we shall call them as x, y, z, right? It's just an arbitrary number at the moment, x, y, z. So we are going to find the vector that connects this arbitrary point with P. So this is similar to how you write the vector PR. So in this case, you have to take the vector, the coordinates, which we are not sure yet. This is x, y, z. So you're going to write x minus the coordinate of P in the x direction. Similarly for the y and z. So in that case, now you have another vector here. And in order to get the equation of plane, we are at the last steps now. The last step involves taking the dot product of this vector with the vector n. And since the point that we want that we take here, which is written as x, y, z, is in the plane of these 3 points, the two vectors, this vector and the n vectors, the dot product is going to be equals to 0. So if you do that, basically you will come up with a set of equation, not a set, but a one equation that will represent the plane connecting these 3 points. So let's take an example so that to make it easier to see. So let's say we have point P, which is written, or which coordinate is given by 2, 2, minus 2. And then we have another point R, which is negative 4, 4 and 2. And another coordinate, which is 3, minus 3, 0. So from this, we will find the vector PR and vector PQ. So vector PR is just taking the coordinate of R minus P. So PR is written here, minus 4, 4, 2, minus 2, 2, minus 2. So here you have minus 6, 2, 4. So this is the vector PR. So you do the same for vector PQ, and I have here 1, minus 5, 2. So basically this is one way of writing the vector. There's another way to write the vector, that is to write I minus 5j plus 2k for this vector PQ. Right. So we go to step 2 now. You are going to take the cross product between the two vectors. And here you are going to get the vector n, which I have here as negative 24i minus 16j minus 28k. Right, so you can check on your own to make sure that this answer is correct. And then the next thing now is I'm going to take an arbitrary point along or on the plane, and I will take this point minus the point for coordinate P to get the vector to connect these two these 2 points, and I call this as Px, a vector Px, which is written like this. So now we are left with the last step. Basically, I'm going to take this vector and I will take the dot product with the vector n, and then I set the dot product to be equals to 0 because they are orthogonal. And then I will have this expression 24x plus 16y plus 28z equals to 24. And since here I can simplify the equation by dividing it by 4, then I will have this 6x plus 4y plus 7z equals to 6. So this is the equation of plane that will connect these 3 points. So here I use a visualization in order to show what we are doing just now. So here the red point is point P, and then you have point Q and R. And now I'm typing the equation of plane which we have obtained just now into the left hand side here, and you will see that this is the plane. So you will see that all the points falls onto this plane, right? So let's just rotate it a little bit and we'll see what happens. So here you see clearly this equation represents the equation of plane connecting the 3 points. So this time around I use the equation which I have divided by 4. So now I have 6x plus 4y plus 7z equals to 6. And here you see that this equation is basically same like the previous one. You have all the 3 points falling on the same on this plane. Right, so now one interesting thing that I want to show you here is basically when you have this equation of plane, you can find a point that is directly perpendicular to this plane. And to do that, basically what you need to do is just to identify the numbers at the front of this x, y, z. So let's say we look at this equation of plane. Our x is going to be 6. So I will type 6 here. For y, the one that is in front of y is 4. And z, this is going to be 7. And then let's just change this to green. So here you see that this point is directly perpendicular to this plane, right? So let me just rotate it a little bit and we will convince ourselves that this is true. So here this is directly on top of this plane. So this interesting point has a very important usage when you are trying to find a plane that is perpendicular to this plane that we have just obtained, right? So but we will leave that for later on. So here what we need to remember is basically in order to find this equation of plane, we need to follow the 4 steps earlier. So what we have done was to, let's say we will just use the red point here. This is our P. So we have find the vector P to R, P to Q, right? We find these 2 vectors and then we take the cross product. We have a vector n that is pointing either this way or this way. We don't really care about it. And then after that we will take an arbitrary point on this plane x, y, z, and we find the vector with respect to P. Now when we have these 2 vectors, the vector n and this vector connecting to an arbitrary point, what you need to do next is just to take the dot products and set it to 0, and that will give you this equation of plane. And from the equation of plane, you can find the point that is directly perpendicular to the plane by simply taking the component in front of x, y, and z.